Notice the office. I think Congress is not in. You can forget I'm not a liar.
Watching something live. Background so that the word and whenever you need the word, I will start. Word. Yep.
No. Four. Four. Ready, Ben? No.
Hold on. Gwinnett roughly is I'm going to start with other simple statements after a brief review. Line 1017. I think that's about where we left off. Or other simple statements. Line 17. Screen if you want to check that out. Or on your screen.
Other simple statements. There we are.
Are you ready? Okay. So, it's more than 2 months. It's the last one of these sections. So, briefly, Not to go back, but I think the key points of language that I've covered so far before we pick up where things are right now. First of all, Python works like a desktop calculator and supports big numbers, as the old terminology goes, arbitrary precision arithmetic on meters. I showed you some examples of how you could raise numbers to some incredibly large powers and how things did get slower, but kept going when you took, say, 2 to the 1024 in Python. I also drew a little bit of Python floating point arithmetic. I showed you some of Python string functions, and some of Python's built-in aggregates. The key built-in aggregates that I've shown you, composite clues, point lists, brackets, tuples, which are curly brackets, dictionaries, also referred to as hashes or associative arrays, depending on your language, which are curly braces with key value pairs. Stay there. Python's phrase for a particular construct is a DICT, D-I-C-T. And a DICT, I showed you different ways of initializing these constructs. For example, a DICT can be initialized as a list of ordered pairs. Material is all in my notes in the example. You can also find this material in the 2 references that I have at the top of my notes. Make one correction to one of the references. Initially, in the old versions of the notes, the Python reference is referred to as being authored by David Asher. That's not correct. Asher wrote the first edition. He eventually co-authored with somebody named Mark Lutz on the 3rd edition, and the 5th, most recent edition, was solo authored by Mark Lutz. That again is the 1,600-page behemoth that has detailed examples with Python 2 and Python 3 side by side in a lot of cases. And they're trying to track both 2 and 3 and are not comfortable as the language as you'd like. It might be worth putting the money up for the Lutz book. Reference has been to this point the Summerfield book, was also in the notes. Summerfield is about 400, 500 pages. It's compact, and I like brevity as a reference. So these sort of constructs are ones you can find in those references, or again is put on my notes at www.python.org in the library reference. So lists, tuples, dictionaries, also a later edition, sets. About a couple of the quirks of data representation stem mostly from a lack of keyboard character. There aren't enough special characters in the keyboard set to give the type of data structure its own unambiguous symbolic representation. Because of that lack of symbology, parentheses are overloaded as well as curly braces. So parentheses also, in addition to being tuple designators, also have their usual representation as order of operations designators. And about that is that if you a singleton in Python, you have to explicitly throw a comma if you have one expression in parentheses. Otherwise, what you have is interpreted not as a tuple, but as a singleton. And actually one case where that would fight people for I in my which gives you one result, and I in my string is interpreted rather as a single value, but with strings in Python, as in other languages, are kind of this borderline case. It's kind of, if you look at them from the left side, they look like atomic values, and if you look at strings from the right side, they look like aggregates. Lists of characters rather than as single values. So I think by that, and that's one that's worth keeping in mind, and is the situation with sets. If you can use sets, that is the empty set. The rather is that's the empty set. Again, because of as it were, overloading, confusion, the double duty of curly braces and dictionary formers and set formers, two of the small gotchas with Python. I did go over one other important distinction, and this is a distinction you must remember in this language if you want to use dictionaries effectively, and assignment effectively. There are two classes of built-in values in Python. Immutables, that is unchangeables, and mutables, or things that can be changed in place. So I have a mutable, an example of mutable is a list. I say x0 equals 4, and I've changed it. Instead, I have an immutable, and that's a tuple. I try to change x of 0. Okay. It gives me the, well, let me do. Okay. I showed you some stuff earlier. Dict list, see if this is right. I think it is. No. Okay. That's right. Rusty too. I have used Python since the last class. I'm trying to get some of this older use back. Okay. List.doc. Okay, good. Let me go back to my notes here. Dir. Okay, sorry. Just back to me. Okay. Okay. And it was done before. Python has built-in special methods. Special methods are by convention preceded by double underscores and followed by double underscores. These special methods are hooked by standard Python constructs. Standard symbolic operators like plus, standard built-in functions like dir. When you execute dir on lists, which you're effectively calling is list.dir, when effectively, think. Okay. So there are some corners of the language that I really should learn better at some point, and one of them is why dir needs some sort of a value whenever it's called on a type. If, instead of another way, when you say dir list, you get a list of methods. So the point here is dir has amongst its methods, I'm trying to find the update method, sat attribute, don't remember all. But what I can do, I can bring back one of the functions earlier that I gave you. Object docstrings. Copy this out. And what we find, and what I'm really looking for, is the one for tuple list. The tuple method. What is that there is no documentation for it. Sorry, it's a while. If you go at list tuple language like Ruby, and convention is there in Python. Becomes important is if you can use a tuple as a for list. You can do that if you need a dict, but you cannot use a list as a key for a dict. And I have written some programs, including some Sudoku solvers. I have used tuples as keys for dictionaries. Presentation, a dictionary where you have tuples as keys is a nice representation of a sparse array. And my Sudoku solver used a dict as a representation of a grid of values for doing the solving. Okay. So immutable, mutable, basic types, those are an assignment. Okay. I also show one other nice feature. Two other features, actually. Multivariate assignment also shows the ability, if I remember, to do relations where you have chains of relational expressions. And that is the first session of set of Python example in a nutshell. Are there any questions about the review? Shaquan. Right.
You load something.
What for that show?
I remember we had the load. We had the load.
I haven't loaded anything yet. The of the object. Okay, again, that's a part of the review I slept over. Standard convention in Python, every function goes into the library has an initial comment string immediately beneath that function. That comment string is referred to as a doc string. Whenever you print dot, period dot, a double underscore doc, double underscore underscore, which we get is the doc string for the object. Okay, and that rinky-dink that's in your notes at line 720 or whatever takes a built-in object or type and does a directory of that object's method and prints on a doc string for each of the methods. Okay, another brief review from another brief point that I made before, refresher. In Python, everything is object. And you think of objects as simply lists of slots, lists of attributes. An object is a bag of attributes. And a lot like Smalltalk, in this, whenever you act on an object, it's sending a request to a particular attribute. So if you say, for example, directory of the list, what the dir method does, the dir function does is look for an attribute called $dir in the object that you're doing the directory of, and invokes that particular attribute. Any Ryan? Rayon Nylon. It's been a long day already. Any questions about it? So let's go to line 1017, which is where we left off. And some of this stuff can go quickly. The assignment statement in Python is dynamic. On languages like C++ and other compiled languages, objects, any object in Python can come and go at any point during an interpreter's evaluation. In C++, if you define a class or you define a function, you have class definition, you have that function definition. Those definitions are immutable for the life of the program. Not in Python. Like was to try lines 10:35 to lines 10:38. It might not be true. So to run this example, since we're coming into the middle of my notes, you could first execute something like A equals 3, and then try dir. Change the width. Is a predicate that I showed before. What the predicate does is to determine whether a value is a member of an aggregation of values. The in predicate is defined in Python for any sort of collection type. Before we something like if you remember this, from the string examples, you can also say,
I can understand the first statement as like S is the string, so if the string comes.
in is membership. Okay, going for line, I'm using Notepad++. If you are using an editor that does not have line numbers, trying a search on phrases in notes. For example, like Dell, quote unquote Dell, quote unquote, which should get you to the neighborhood. Making sense, Shaquan, in terms of what in is doing. In is essentially collection membership.
Yes.
And what collection membership means is based on the type of the collection.
Yes, but I have a opposite feeling. As you give this example, for this example, I can understand like ATR is a string, so ATR is in string to be string.
Right.
So for here, give me a sense, look like it's like TR third is in A. Because A has a lot of particulars, but third is one of those.
With dir, use it this way. It's dir is returning a list. Dir is giving you the attributes of an object, but essentially dir is returning a list. And when you say something like X, quote unquote, in dir, which is this particular value a member of that list? And in this case, whenever you define a value, yes, defining a value puts that value into your environment. Dir, with no arguments, gives you the contents of your current environment, all the different identifiers that you find in that environment. Because probably haven't defined A yet.
Oh.
Okay. Yeah. About 5 minutes ago, whenever I first put this up, I said, well, we're jumping in the middle of the sequence of examples, and you need to prime the example to get that thing to work. Is that working better for you, Patty? So the point is del. You'll be able to del the identifier and get rid of it. Gone. And check with X and dir. Gone. Later on, I will show you an example of functions, removing functions, as well as identifiers. Okay. The defs for functions are executable statements that place function objects in your environment. And you can, in fact, in Python, write a function that deletes itself. Runs and deletes itself. And I will chat a little bit later on. Okay.
Dave, can I make a comment?
Yes, Dave.
People want to use line numbers with VI. You do a colon, space number, and then return. Colon, space number, return will put line numbers on your display for those using VI. I thought people were asking about that.
So essentially what you're doing is you're doing the line editing mode, and you're saying this, right?
Colon puts it in.
Colon, it drops you down to the bottom, and then
That's right.
you type set number, return.
Correct. Numbers with VI.
Yeah.
I thought I heard somebody talking about that. So.
The next sequence of the statement is showing import. We did a little bit with import before. Import up above the block of description. To try running 10.3 to 10.52 to see get what I assert that you should get. observations of people here at Building 5100 as a way of gauging whenever people are remote with these exercises. It looks like stuff is going pretty well here. Whenever fingers stop, I'll talk again. And then if anybody has any issues with remote, I'll pause and ask for questions or comments. And that way, Hong, Dave, and Ryan and his
So
people.
I should stop posting
Well, unless saying complimentary things about the course.
Hear me?
Yes, I.
You know what's going to come from you.
We do from sys import path. Is it better to be more conservative that way rather than just import everything? Like press import star?
You can import star. You can say from X import star.
Is that good or bad form?
And say, is it the difference between writing production quality code and working Python
Oh, this is different. Okay.
to get stuff done? I were writing, the people who talk about production quality Python strongly recommend use the form import name and then using whatever period qualified names, path qualified names, as making it explicit that path is an object that's part of the sys module. People who are sticklers about this, in short, wouldn't even necessarily say from X import Y. The own part, I don't mind writing it from X import star. I do sort of thing routinely whenever I'm hacking stuff together.
Oh,
For example, that's how you learn. That's one of the ways you learn. I learned a lot about sys from saying from sys import star, and doing stir, and watching everything pop up in my environment and starting to play with the different names that showed up.
How we should deal with Python library of package, right? That's the natural way to learn.
Well, the need to learn a language, for me, any language or any library, is start writing small code examples and watching what happens with the codes. These notes, these examples that you're looking at, Shaquan, are all derived from sitting down and working and trying stuff and saying, how can I do this and how can I do that? Okay. Just going and trying things out. There's different ways to try to figure out what's there to try. I'm the sort of person who just doesn't want to take time to go to the library reference and start thumbing down and seeing what's there. There are moods where I will read a reference manual. There are moods where I don't want to have anything to do with the reference manual. The cool thing about Python is if I get tired of a reference manual, I can import a bunch of stuff, look at it by doc strings, and then if I like my environment is too cluttered, well, environment's clean. I put together clean. I've exited and I've restarted with a clean environment. Have I addressed your question, or have I talked about something completely different from what you were asking?
Because in practice, there's a lot of case that I will have code any Python library we write. I need to use file one or some special package, you can invite from. All I get is the package. So the fastest way to learn my work is kind of just like this, import the whole package and see the
Maybe.
and
The-
use
the-
the talk to see each one of it.
Maybe.
Documentation.
Because the most X import star doesn't necessarily bring everything into your workspace. Okay?
No,
In a module, let me explain. Let me explain. What are modules? We haven't gotten to part of the course yet where I've shown you how modules work. The way it works is you have a file. The file contains a bunch of functions. In addition to the functions, the file contains a special identifier called _ALL, all. And that identifier refers to a list of identifiers. Those identifiers are typically the names of the identifiers in your file. So if the designer of a library has functions called A, B, C, X, and Z, and all equals A, B, C, X, Y, Z will not be imported into your space. From Guy's module import star does not bring in X, Y, and Z. However, if you say my guy's library.x, you can still access X. Now, probably a reason that the designer of the library made X, Y, and Z private. Then again, sometimes designers of packages don't get everything right and expose functions that shouldn't be exposed and vice versa. So, some library import star is a good first approximation to getting a sense of what's out there that's important, but it's not necessarily the whole story. Does that make sense to you? Okay. So, you can copy and paste if you like. Drop down, has assert, has these. And I'll make a comment about assert or raise after people just try these out. Again, if you want to type them in by hand, that's great. If you copy and paste, that's great. And typing by hand gives it more motor memory. Fairly standard stuff, but I'm going to do a quick commentary on assert statements. A point of languages, and this actually includes Python, that troubles me. Remember on Goddard, a guy that taught at ETHU, one thing that taking error checks out of working programs, the programs that supposedly work, is like designing a car, taking it out to Detroit, running the car on a test track and saying, okay, the car's fine, we can pull out the brakes because the brakes are important anyway. There's a standard practice, and I've seen this in the Visual C++ environment, and I've seen this in Python. Assert doesn't always assert. And I have an example, maybe, I'm not sure if it's here, but I have an example somewhere in my Python notes, where if you start Python with a -o, an I switch, and run and assert 1 = 0, nothing happens. And exactly the same thing you get in Microsoft Visual Studio if you choose to compile a package in production mode rather than debug mode. Theory, I think, is that asserts, once you program and it passes all the assertions, then you tested enough and it will probably work just fine, and the assertions only slow you down if you're running. To me, which is one of the more stupid ideas that I have seen in software engineering. But it kind of, in a way, goes, it highlights this design by contract, which is where all this stuff about getting the certs originally came from. One geniuses in software engineering is a French guy named Bertrand Meyer, who in a language called Eiffel, which to me is Java and C++ done right. It's what those languages should have been. Unfortunately, it didn't get market share or mind share, and it's only see it in certain small corners of Europe. There are a bunch of really slick ideas for handling problems. And one of the slick ideas in Eiffel is have the ability in each of your methods to define conditions and post-conditions. You have a pre-condition section, you have a post-condition section. You can also define invariants. For example, this loop should always get progress towards the goal, more or less. The Eiffel is if you have a really smart compiler. Smart compiler can take the preconditions, the static analysis on your code, say, and verify that the preconditions will always be met from all paths coming into your function. And the compiler can say the preconditions must be met, we can talk them out. So a really smart compiler, starting from the preconditions, can perhaps infer that the post-conditions will always be true. And if the post-conditions are always true, the compiler will optimize them out for you. If the compiler can't make those inferences, then your compiler can leave them in. So you have guarantees that if you trust a static analyzer, and I trust Bertrand Meyer stuff pretty much from what I've read of it, you guarantees that it's safe to pull these run checks out of your program, as opposed to this making where, okay, we optimize and we get rid of all of our checks and we pretend they just don't exist anymore. Okay. So here, if you ever see a language that has an assert operator in it, use the assert operator, but be very careful to check the language to see if there are any reasons conditions under which assert might not work. The other interesting thing about optimization in Python is optimization in Python is really an obsolete switch. The optimization switch was included in Python 1 because Python 1 included line numbers or some sort of metadata related to the compilation of the program as of the bytecode compilation. And read of the old Python notes that additional information made the program fat, made it run very slow. And the optimization took out that meta content as well as disabling the assert. That particular went away with the redesign of Python 2. So there is no good reason to run Python with the -o optimization command line switch. Comments or questions? So, compound statements. Pretty much what you're using in most languages, sort of. If, for, while, try, break, and continue. There is no do until in Python, as in Pascal module. Whites, and we've seen this as is used in Python instead of begin and end. Now, examples in just a bit here. If you want a block of statements full and if, you indent a certain number of spaces and you be consistent until you reach the end. Consistency means if you have been impacted all the way, you space in all the way by the same number of spaces, and if you mix tabs and spaces, you can do that, but you be consistent. Practice is not to use tabs for reasons, one of which is a different editor shows tabs differently and drives you crazy. I kind of prefer the Ruby convention, where all are spaced in by 2 spaces, just enough to make it obvious that you're in a nested block, but not enough that if you have to nest somewhat deep, you run at the end of the right side of your page. Okay. Potential gotcha that you've seen in this class is that tuple function and class definitions and block structures must be followed by a totally blank line. We see before where people have done things like for I from in range 10. Oh, sorry. Sometimes I do things that are Python. So at this point, I hit return. And if space out, it keeps going. Even though what we have looks like a blank line, it's not really a blank line. And if I space 4 in, the fact that I spaced 4 in, Python should have complained about inconsistent spacing, but did not. So there's something a little bit weird there going on. Let me a little bit of inconsistency that I'm looking for. If I print I statement, then expected indent. Apparently, the tab nanny doesn't kick in unless you expressly have some sort of an expression online. But know where this gets confusing. Tax error there because I'm trying to start a second loop and I'm not leaving the blank line between first at the top level and for season. I understand Python complains at the top level, but does not complain about this at an inner level. Be doing questions a little later on. Yeah, my phone. sorry, for I in range 10, for I, for j in range 10. Print j. So you do that sort of deal where you don't leave a blank line between blocks in a nested scope. The top level scope, and I found what I'm showing you to be true for files as well. You need a totally blank line between isolated blocks of code. Okay, and I will show some examples. Any questions or comments so far about these little syntactic gotchas? It calls it the tab nanny. Yes. If you do it on tab nanny, that's what you will see. Okay. Python's if statement is inspired by an old language called Modula that introduced if, else, with the final else clause. Show an example of that later in a little bit. For in Python are unlike for statements in Fortran and the first couple generations of generative languages. Limited use, or say something like for I from 1 to 10, do print note or format, whatever. How did you invoke a format statement in Python in Fortran? Was it print and then you have like print 10? Yeah, print line 50, whatever. Okay. Python will allow you to iterate over ranges of numbers, but Python will allow you to iterate over anything that produces a sequence of values, over anything that produces a sequence of values. The first place where I saw iterate over sequence was the Bash shell language. And I remember being blown away by the fact that you didn't have to stay with 1, 2, 3, 4, 5 in order to get your numbers out. And you don't have to in Python either. You can say something like for S in well, it's cool, and that particular concept applies in Python to the notion of an iterator or a generator function. That clause, instead of being a list or data structure, can be a function that has called a yield statement, and that will coming up, and can in effect write a for loop that goes as deeply into, say, a Fibonacci sequence or a sequence of times as you like. It's a generator that yields the list of primes. Okay. In another way, Python allows you to do what the old school programmers back in my day referred to as coroutine. Have two functions, A and B, and B has a memory of where it left off. It calls B, B does a little work, remembers where it was, gets back to A. And that later in this list of examples, how you can do that sort of coroutine and that sort of generator in Python. It's really fairly simple. So, another surprise for me, and I thought I read a little bit more Java, have finally is correct in Java. I've never seen it before, but if you learn Java, you understand what find really does. I will show find a little bit later. Tell you what, try, instead of typing this stuff in by hand, try picking off 130 through 1130 to 1147. Try copying and pasting those to your Python interpreter. Run the magnitude after that. Then once you've done that, do a quick talk through of the logic there. So I mean by copy and paste is just that. Copy. Let me make sure that it's working. Okay. Oh crap. I'm plugging my phone. With the do to me. Well, I expect that. I'm going to debug it. I'm not going to debug it on the fly. To go back. I promise people working version of the extension for next week. Just my homework. I do integer division. Maybe the problem, I need to do integer division, but I think maybe what I need to do instead of integer division is floating point division and for closeness to 1. I'm not, the other thing I may have to do is integer division, integer remainder, and put a remainder check in. Something like x copy remainder equals x copy / 10 comma x copy %10. But I'm not going to do that today. I'm going to fuss with that a little bit. I do want integer, just thinking about this, Ryan, I do want integer division, but maybe I need to check with remainder check as well. List of homework. So, homework, fix magnitude. Write that down. Where do you stand in the room in terms of copying and pasting and running the example. Shaquan, have you done a few things here? Have you gotten this to work?
Yeah.
Okay. Have you gotten this to work, John, as far as it goes? Okay. Ryan, do you think stand with you? Bobby?
It's a tough one.
All things considered, I guess I'm okay, but,
Well,
Just let me know if that means, handle it.
no. I deserve what I get on this one. I need to do the remainder check there. I need to add a remainder check to that. We'll do that tonight. You?
Yeah, I'm just finishing up my drawing the different values about here.
Okay. So, are you good? So really, the main point of this example is to ring the changes on a few of the constructs that I discussed earlier. We have an assert, and the assert is used to kick out stuff that isn't a number, and the use of isInstance, which is a Python built-in to see whether the argument is either an integer or a floating point value. So with those sorts of numbers in this particular routine, and I'm following again the Ruby convention of two-space indent. If, else, again the modulo, else. Now this is one of the things that if you've ever seen Futurama, there's Crazy Eddie robot in Futurama that gets really excited and the head blows off when Crazy Eddie gets too excited. This particular while else is one of the things that did a Crazy Eddie to me when I saw it. I had never seen an else on a while loop in any other language, but you can throw else on a while. It's kind of like you can throw else on a for as well in Python. And with that, it's essentially equivalent to just dropping out of the one, as far as I can tell, but I try to use it. Okay. So here are other small examples of stuff. If you were good, if you drop down now to the four examples, the loop examples, and try running the first examples. At the end, if you had an end keyword to print statement, you force prints the values that the print statement generates to lie on one line. And the punchline here is the third example that shows the use of the else. And if finding that third example, oh, it's been a while. On those examples again. For example, that example. Third example. Okay. So what's the difference? Now that I've looked at my own examples again and remembered what I was doing, what is the difference? What's going on with the second and third example?
We are going to talk one method I one to the boundary of the range, the other one is that I when put my with the code. So if you have a typo in one of them, you see the y.
There's another point going on here. The point is about the interaction between which features. Okay. And when I that you need to experiment with constructs to get a feel for how the constructs work, particularly you get weird things happen when you get interactions that aren't necessarily explained in language references. You have this construct called break, you have this construct called for, you have this construct called else. Talk about break, talk about for, talk about else. What happens when you put them together? What's going on with the break in the third example does not happen in the second example? Saying to start with the second example, what problem is an example trying to fix if the first doesn't fix? What that can do? Right. This first example, John is right. This first example, list from 0 to 9, then put a new line in. Agreed? No. Second example, use else to its lack of a new line. Right kicks in whenever I drops out of range 0 to 10. At that final print, which is the new line. So 30 example.
Because the full break when I equal to 9, so the full opportunity to have not
Exactly. What's happening is that this example is showing that the break bypasses the else. The break drops you completely out of the construct. So you have a chance to execute the else clause. Again, examples are for me were crazy Eddie moments of my the behavior of little things in the language. Here's another example. Here's an example of a generator. I promised you a generator and iterator before on to example 4. Verifications that we read about this for those first 3 examples. Bobby, making sense? Check one.
I confused. You have 2 types of program control. You have the do loop, you have the if statement, the break structure. The here you mix them together. You kind of like possibly doing the do loop, possibly doing the if statement to branch out the code.
It's not uncommon to write breakments in loops as a way of trying to address conditions that loops don't express perfectly. Class examples while true. Doing something until you have hit some sort of a condition. Your condition is if whatever break. A second issue can be if you hit some sort of a unexpected value in the sequence of values that you're processing. Okay. Now, one of the differences between else and finally, understand, is that if you put an else in, the else kicks in after your loop expires. It won't kick in if you break out of the loop. If finally in, I believe, and I have to check this, the finally executes even if you break out of the loop. So subtleties here constructs, and these subtleties typically aren't that important for situations where you're processing input and you know exactly what it is that you're dealing with your input. All these become important when you're dealing with the sequence of input, and you cannot precondition the input coming in. You have to process and audit at the same time. And if you're processing a stream of data that's not been preconditioned and you're auditing it, it's a need to understand what these side clauses are in languages to support else and finally and what they're doing for you. And these examples are meant to show that. Is that any clearer of an explanation as to why I'm including these examples here? And again, including examples in part because I looked at the conspec. I've never seen a language that had else on it before. I've never seen a language that had finally, since I've never done Java. And my first inclination when I'm working working with learning a new set of tools is to start using the tools and seeing what they're good for. Okay, example 4. Here's the iterator. To either type in or copy and paste lines 1198 through 1207. Try it and we'll talk about it. Lines equal 4. My editor's lines 1198 to 1207. Okay, are you happy with the example? You're probably been sitting there and thinking about other things for the last 2 minutes, right? Okay, good. Ryan, are you satisfied with the example? I'll explain that in a minute. It's a fair question. Okay. Patty, are you satisfied with the example? Should you be satisfied? Bobby, are you satisfied? Okay, for people who haven't seen ORD before, ORD translates a literal to a collation sequence value. Okay. Another way of saying that there are different conventions for mapping principles to numbers. One is EBCDIC, the extended binary code. Is EBCDIC short for? Is extended binary coded decimal something or other, an old IBM standard. This particular Python right now uses Unicode, is the child of ASCII, probably this UTF-8. And UTF-8 gives you is a mapping of the letters from lowercase a to lowercase c. The represented values, let's see, lowercase a, I'll say is 65. Lowercase a is 32 plus 65. Does 97 sound right for lowercase a? Python company. Gold and green. Okay. Okay. So what's happening is in the ASCII or the UTF character sets, lowercase a maps to 97, lowercase b maps to 98, lowercase c maps to 99. So if you keep adding 1 to the code for letter, you keep adding the next letter up until z. Okay. In the for loop, is not running over numbers, it's running over letters. It's not only running over letters, it's really running over a function that yields a sequence of letters. And if I take the lowercase letter function and alternate between print numbers and printing out the letters and printing out the codes they represent. I can pack that up real. We'll do something a little bit different, a little easier. I'm going to go back further than that. Letters. This letter gets ordered, fine. Letter ordered Z. This letter gets letter plus 1. Yield character. Let's look pair and see what happens. Okay, so we're yielding a pair. Where's for loop? Rather trying to go back through the for loop. See what we get. We're building a list of characters paired with the ASCII values, the UTF-8 values that their character code corresponds to with no return. Okay. Yield differs from return in terms of what yield statement directs the Python interpreter to do bytecode. You have return defaults to a routine. Start out with completely clean state. You have a routine paradigm where calling A does something different from every time. There's no memory. Is it defines what Python refers to a generator, and it's kind of a lot like the old idea of the code routine, where instead of coming to the function clean, you up at the point where you last yielded it. State is preserved, and in this case, execution comes back to the while. So, if our values out of a generator, loop down until the value stream stops. What I'd like to have you do is to find lowercase letters and change the definition so that the while clause, instead of saying while this letter is less than the word Z, change while true. And then the loop and see what happens. Yes, John. Who has a question first? We'll change it around to make you happy in a minute. I'll put up an equivalent one. It's a good question. I'll put up an equivalent one in just a minute. What I like to do in the meantime is to try a while true. Put that another way. Change what we have here to while true.
The full name, full name.
Capital truth. Sorry. On case sensitive, you need, it's my fault, my mistake. You have to say capital truth. So, as on the, as shown there.
There's a lot of random code.
Thing you can do is go into the text file and change the condition to make it get rid of the text. While this letter is less than word, please simply make that a while true. We will be sending out an updated version of the for next week because I need to fix the magnitude function anyway.
Everything. I don't need to know anymore.
What's happening? Let me show people on the screen what people here see. Okay, my Python interpreter gets a certain point and just dies because it's trying to find symbolic representations for numbers that don't have them. And that's what you get with Windows. Apparently with the Macintoshes, it just keeps going, doesn't it? Try to see eventually. Control C working? Okay, eventually. Okay, so the point of that example is to show that it is possible to shoot oneself in the foot, writing an iterator. Now, John wanted was this. That works. Let's who rather start with A rather than one before A. Does that work, John? If you don't want to overstep the range, there is one other way of doing this. Okay. And there are some contexts, particularly not Python, which is cool because Python does give you the arbitrary precision integer arithmetic. There is no maximum integer. But there are languages like Java and C++ where you have to be very, or C# even, where you have to be very careful about not pulling a particular limit. You have to write code like this, where you make sure that you stop short. For that particular formulation of the logic is kind of elegant in the sense that this letter never gets to a value that's greater in order to keep that. So, again, the difference between a generator and a regular function is to use yield rather than return. Put back a value, yield, and use the generator the next time. The generator will pick up at the statement after the yield. Okay. Other way to stop a generator is to raise an exception called stop iteration.
The generator will pick up after what now?
The statement immediately after the last yield. So, for example, in the version of this function you see here, the first through that returns after line 1201, A. This line, we call it, it starts at line 1202, goes back into the while, return B. The third call that starts here, back through the loop, returns C. Eventually, this becomes the equivalent of a Z. You drop an else case, yield this letter one last time. And the function drops when it goes off the end. Here's what I mean about stop iteration. Not yield. Okay, done? What you do?
Okay, so
You're right. You're right. Debugging that. Well said, John. I screwed that up. More sense. Let's write and see what that does. And this, we'll do one more trick with this. And we'll do one other trick. This parameterize our stopping point and execution of that loop relative to your try stopping point. Again, go in the room. Are you satisfied with what I've just shown here?
Yeah.
Bobby? John? So let me undo some of my machinery. The original. I like that version of it. And it's a little bit more time. Let me ask you to move to example 5. Try that out. How's it look at you? Did you get that to work? Ryan? What's your point?
Yeah.
John? Okay. Really, these rules are illustrating the point that the generator logic is no different from a routine, except that you have the creation of a sequence of values. Okay. One reason that you'd want to use a generator rather than a regular subroutine is memory conservation. Any examples could have been done with a function that carved up the entire list back off to the subject made the request. But then you'd be passing back a list of 26 values. The beauty of the generator is that you're obtaining values one at a time. Easier consumption, easier on the garbage collection. It's very efficient. Doing returns is more memory efficient, but you have a space-time trade-off. Trade-off is you do make the 26 calls. Generators are pretty fast because what you're effectively doing is you're doing jumps, but you're not even passing parameters as part of the jumps. One of the important things about the generators is the generators are not re-entrant in the sense that you don't have to reprime the state. What do you think, number 26? I mean, example 26. I'd like you to try example 26. On example 6, it's at line 1226. That's why I'm calling it example 26. I actually use stop iteration here. This is the classic Fibonacci series. Where you think two intermediate values around for the streamlining the computation, and you're printing the next value by adding the two previous values, and you're updating the two previous values. Doesn't look too much different from what you've seen before, except that what I have done is to drop the generator into a list comprehension. What would happen if I did this? Guesses before I do it.
Will do everything or will do that?
Yep.
Okay, Ryan and Nessus. This is another one of those aha moments that I discovered when I discovered something about the language I didn't know by trying something and watching what's happening. Why isn't Python printing anything?
You confused it.
The list comprehension is trying to generate the entire list before returning anything.
Oh,
Exactly.
might have to
essentially, it laid on this for long enough, either my computer would run out of memory or Python would run out of memory. And whenever I did this, yeah, I can't even control C out of it. Computer is hosed. My Python session is hosed. Okay, it's gone. And it is 4:55. So and beyond. This is example, so I'm going to have to change that too for next week. 12:57. I have to write that down. Exam 7. So we'll start here next week, and we haven't gotten through. Well, we're almost out of section 4, and that's a good thing. Do you have any final questions before we shut down the conference? Comments? Patty? Ryan? John? Bobby? I think what's happening with the list comprehension is that a list comprehension tries to materialize the entire list, as opposed to the print statement, which is not trying to materialize an object that iteratively. I heard about that myself. Why that one infinite loop, the generator, progress and the other does not. And that's my belief. It's trying to materialize the whole list before showing anything. And that takes. Questions from the remote participants?
I'm good. Thank you.
Dave?
Seeing that.
Okay. Well, you're welcome. Thank you for participating.
Thanks,
And
Phil.
I guess what we'll do is, Charles, thank you. I guess we'll shut down then.
Yeah, I guess we'll put down for next time. Thanks, everybody. We'll see you then. Well,